that is common out. So here 2 cos theta value, that is pi by 2 minus theta by 2, that is take a common, here raised to n as it is. Remaining term, that is only cos theta by 2, that is cos pi by 2 minus theta by 2. Now in second set, remaining term, that is only I sin theta by 2, that is plus I sin theta, that is pi by 2 minus theta by 2. And same way raised to n, that is in both the case as it is. Now we want to simplify this set of equation. So raised to n, here 2 raised to n, here raised to n, that is cos raised to n pi by 2 minus theta by 2. So we can write here 2 raised to n, here cos raised to n, here pi by 2 minus theta. Now we simplify our angle, that becomes pi 2, that is take LCM, that is nothing but minus 2 theta, and by 2, that becomes finally 4. So we can write here pi minus 2 theta by 4. Same way we want to simplify this angle also. So cos pi minus 2 pi by 4 pi minus 2 theta by 4, and here raised to n. So this raised to n, that is angle multiply with theta. So here n. Now second term plus I sin into n, now into theta. So we want to simplify this theta, that becomes same pi minus 2 theta by 4. So here pi minus 2 theta by 4. Now again we want to simplify this set of equation. So 2 raised to n as it is, cos raised to n, here by 4, that we take both the side, that is pi by 4 minus 2 theta by 4, that becomes theta by 2 only. Now again we want to simplify this term, that is nothing but in bracket cos, here angle simplification, that is same pi by 4 minus theta by 2. So our angle becomes multiply with n only, so that is n pi by 4 minus n theta by 2 plus I as it is sin n theta. So again we want to simplify this angle, that is pi by 4 minus theta by 2 as it is. So that is n pi by 4 minus n theta by 2, bracket complete. So this step, that is simplification of only this term, 1 plus I theta, 1 plus sin theta plus I cos theta raised to n. Now this is our equation number 1. Now we want to simplify this term, 1 plus sin theta minus I cos theta raised to n. So only difference, that is here plus sign and here minus sign. So we can directly write our equation, that is here plus sign and here minus sign. So our equation number 2 becomes our sign, that is as it is 2 raised to n cos raised to n pi by 4 theta by 2 bracket as it is cos n pi by 4 minus n theta by 2. Here minus sign, minus I, so write directly minus I sin, here angle that is as it is, n pi by 4 minus n theta by 2. So this is nothing but our equation number 2. So we find out our two set of equation here. Now just we want to add, because the sign that is addition sign. So if you want to add equation number 1 and 2, so write here add 1 and 2. So if you want to add this two term, then in both the term contain 2 raised to n cos raised to n pi by 4 minus theta by 2. Here first term and second term, so we take common out, so that is 2 raised to n cos raised to n pi by 4 minus theta by 2 as it is. Now cos n pi by 4 minus n theta by 2, and here also contains same angle cos n pi by 4 minus n theta by 2. So if we add cos theta and cos theta, then means 2 cos theta. So this is nothing but 2 cos theta, that is n pi by 4 minus n theta by 2. Now look at here, here plus I sin theta and minus I sin theta, because both the theta that is common. So ultimately that is cancel out. So only remaining term, that is 2 cos n pi by 4 minus n theta by 2. So if we add only real part equation, so now finally here 2, that means 2 raised to 1. So and here 2 raised to n. So ultimately we can say 2 n plus 1 addition of the power, that is 2 raised to n plus 1. Here second term, that is as it is cos raised to n, here pi by 4 minus theta by 2, and finally our last term, that is cos n pi by 4 minus n theta by 2. So this is the final simplify step. Now just check it out. That is nothing but our proof. 2 raised to n plus 1 cos raised to n pi by 4 minus theta by 2. So here 2 raised to n plus 1 cos raised to n pi by 4 minus theta by 2. Here cos raised to n pi by 4 minus theta by 2. Here cos n pi by 4 minus n theta by 2. So here cos n pi by 4 minus n theta by 2. So this is our final answer we can prove here. Now we move to our next question. Next question, that is prove 1 plus I raised to n plus 1 minus I raised to n is equal to 2 raised to n by 2 plus 1 into cos n pi by 4. Now we write down our question first. That is 1 plus I raised to n plus 1 minus I raised to n is equal to 2 raised to n by 2 plus 1 into cos n pi by 4. So here our value of complex number, that is in terms of power, so 1 plus I. So our rule suggests that both the angle must be same, but here no any angle, only term that is 1 and only term that is I. So if we want to convert 1 plus I raised to n into polar form, that is nothing but theta term, so here theta plus cos theta plus I sin theta. We want to convert this term into cos theta plus I sin theta term. So at which part this cos theta ultimately we want to finally 1, and this sin theta ultimately we want I, only I term. So here we want to 1 and here again we want to 1, but angle must be same. So just look it out at which part of theta. Here we write basic step, sin 30 degree, that is 0, cos 30 degree, that is 1, sin 0, that is 0, cos 0, that is 1, sin 30 degree, that is 1 upon 2, sin 45 degree, that is 1 upon under root 2, sin 60 degree, that is under root 3 by 2. So just reverse case, that is in cos angle, that is here under root 3 by 2 and here 1 upon under root 2. So we can communicate with angle 45. So at 45 angle, cos theta and sin theta, both the value are same. So this 45 angle we can write here pi by 4 also. So if we write cos pi by 4 plus I sin pi by 4, then cos pi by 4, that is ultimately 1 upon under root 2, but we want only 1, so this becomes finally 1. So if we multiply with under root 2 into 1 upon under root 2, multiply and divide under root 2 and under root 2, so this is nothing but cos pi by 4, that is 1. Now here sin pi by 4 value, that is again 1 upon under root 2. So same case we can multiply with under root 2. So finally we can write here under root 2 into angle term, that is cos pi by 4, this 1 upon under root 2, this is nothing but cos pi by 4, plus I sin this 1 upon under root 2, that is nothing but sin pi by 4. So we can write 1 plus I into cos theta plus I sin theta form. So just check it out, reverse step, under root 2 into cos pi by 4, that is 1 upon under root 2 plus I sin pi by 4, that is 1 upon under root 2, and under root 2 multiplication, the result, that is 1 plus I. So if 1 plus I raised to n, then here raised to n. Now we want to simplify it. So under root 2 raised to n, here cos this power multiply with angle, so that becomes n pi by 4 plus I sin this power multiply with n, that becomes n pi by 4. So we can simplify 1 plus I raised to n in this way. So this is becomes equation number 1. Now we want to simplify 1 minus I raised to n. So this becomes only under root 2 cos pi by 4 minus I sin pi by 4. So we can write 1 minus I raised to n is equal to under root 2 cos pi by 4 minus I sin pi by 4 raised to n. So we can easily simplify it, under root 2 here cos n pi by 4, so power multiply with angle minus I sin, here power multiply with angle, that is n pi by 4. So this is nothing but our equation number 2. Now with question we want to add two equation, equation number 1 and equation number 2. So add 1 and 2. So first equation, that is under root 2 raised to n cos n pi by 4 plus I sin n pi by 4 plus this term, equation number 2, that is again under root 2 cos n pi by 4 minus I sin n pi by 4. Now we just simplify. Here under root 2 we can write 2 raised to 1 upon 2. So 2 raised to 1 upon 2, that becomes under root 2 into n cos n pi by 4 plus I sin n pi by 4. Second step, under root 2 raised to n, so under root 2 we can write 2 raised to 1 upon 2 into n, and remaining term, that is as it is, cos n pi by 4 minus I sin n pi by 4. Now we can simplify, or we can take a common, 2 raised to 1 upon 2 n, so that is 2 raised to n by 2, take a common from both the equation, so remaining term, that is only here cos n pi by 4 plus I sin n pi by 4, and from second set of equation plus cos n pi by 4 minus I sin n pi by 4. Now we want to simplify again this step. Here plus I sin n pi